Dear students, now we are still at the functions. You know the definitions and basic properties very well from the previous sessions. Now coming to this session, we are going to explore some special types of functions. Right? See the first one, exponential function. If a greater than 0 and a not equal to 1, then f of x is equal to a power x is called an exponential function. F of x equal to a power x, generally some students are not familiar. Simply here exponential function means f of x is equal to some 2 power x, 3 power x, 5 power x and 1 by 2 whole power x, 1 by 3 whole power x, that is like this. They are called exponential function. Right. Now, what is the domain of an exponential function? Domain of an exponential function. Domain of an exponential function is a set of all real numbers. Now, what is the range of exponential function? What is the range of an exponential function? That is equal to set of all positive real numbers, that is also denoted by open interval 0 comma infinity. Right. Now we draw the graph of exponential function in two cases. The case one is a lie between 0 and 1. If a lie between 0 and 1. Now, what is the shape of the graph in this case? Right? So here a lie between 0 and 1, f of x equal to a power x, x tending to minus infinity, x tending to minus infinity, f of x tending to infinity, x tending to minus infinity, f of x tending to infinity, at x is equal to 0, at x equal to 0, f of x is equal to 1, as x tending to infinity, f of x tending to 0, that is they are the values. Right. Now the graph of this function is like this. The graph of this function is like this. Right. This is infinity, minus infinity to infinity. This is a point 0 comma 1. This is a point 0 comma 1. As x tending to infinity, f of x tending to 0. Right. Observe the graph. Here the values of x increases, then the values of a power x decreases. The values of a power x decreases. So in this case, f of x equal to a power x is a decreasing function. Right. Now in the case of a greater than 1, in the case of a greater than 1, as x tending to minus infinity, f of x tending to 0, x tending to minus infinity, f of x tending to 0, at x is equal to 0, f of x is equal to 1, as x tending to infinity, as x tending to infinity, f of x tending to infinity, f of x tending to infinity. Now the graph is like this. Right. This is the point 0 comma 1. Right. This is x tending to minus infinity and this is x tending to infinity. Right. Observe the graph. If the values of x increases, then the function a power x also increases. That's why this is called an increasing function. Also, observe that this is the inverse of a logarithmic function. Right. Now, step function, that is also called greatest integer function. That is very important for solving the problems in calculus. Right. What is step function? How it works? What is the graph of that function? What is the continuity and differentiability of this function? Right. See one by one. Right. If x belong to R, then the greatest integer less than or equal to x is denoted by box x. This is box x is called the integral part of x. This is the main point in this definition. This is integral part of x. Right, consider a real line minus infinity to infinity. Right, what is a step function? What box x denotes? Right, let x be any real number. Let x be any real number. X belong to R. Right, suppose x is equal to 5. X is equal to 5. 5 can be written as 5 plus 0. 5 plus 0. This is called integral part. This is called integral part. This is called fractional part. Right. X is equal to 5. 5 can be written as 5 plus 0. 5 is called integral part. 0 is called fractional part. Box denotes the integral part of any real number. Box denotes integral part of any real number. Right. In this case, box x is equal to 5. Right. Similarly, x is equal to minus 2. X equal to minus 2. That is equal to minus 2 plus 0. In this case, minus 2 is integral part, 0 is fractional part. That implies box x is equal to integral part. Box x denotes integral part of that number, that is minus 2. Box x is equal to minus 2. Right. Suppose x equal to 5.7. X is equal to 5.7. That is equal to 5 plus 0.7. 5 plus 0.7. Here this is integral part and this is fractional part. Box x or step function denotes integral part of any real number. So here the integral part of this number box x, that is equal to 5. Right. Now x is equal to minus 5.7. X equal to minus 5.7. In this case, generally student says the integral part of this number is minus 5. But this is wrong. Right. Minus 5.7 can be written as minus 6 plus 0.3. Minus 5.7 is equal to minus 6 plus 0.3. Because the fractional part is always non-negative. Fractional part is always non-negative. Right. In this, the integral part is the integral part of this number. The integral part of this number, that is equal to minus 6. Right. So this is box X denotes any real number. By observing from the real line, suppose x is equal to 5. X equal to 5 is integer, so its integral part is 5. Suppose now we consider minus 1.3. Minus 1.3. What is the integral part of minus 1.3? The immediate left integer, is box X. The immediate left integer, that is minus 2. What is the integral part or the box X value of minus 2.5? What is box of minus 2.5? That is the immediate left integer is box X. Similarly, in positive real numbers, 1.7 is a real number. What is box of 1.7? Box of 1.7 is simply the immediate left integer is box of 1.7. Right. Now, what is the integral part or the box value of 3.3? The immediate left integer is its integral part, that is also denoted by box X. Box 3.3 is the immediate left integer, that is 3. Right, that is step function or greatest integer function. Right. Now we will see what are the properties of this function. Right. The first and very important property of this step function is x minus 1 less than box X less than or equal to X for all X belong to R. This can also be observed from the graphs of individual functions. We draw graph of y is equal to x minus 1, y is equal to box X, y is equal to X. From that graph also observe that x minus 1 less than box X less than or equal to X. Right. This is true for all X belong to R. Right. If X belong to Z, what is box X? If X belong to Z, then box X is equal to X. Then box X equal to X. Now, X belong to R minus Z, X belong to R minus Z, then box X is always less than X. Right? Box X less than or equal to X for all X belong to R. R can be divided into two parts. The first one is integer and non-integer. If X is an integer, then box X is equal to X. If X is a non-integer, then box X less than X. Right? Now, the second one, if f of X is equal to box of X plus n, this is equal to box X plus n. This is possible only when n belong to Z. That is very important. This is possible only when n belong to Z. See one example. Box of x plus 1, that is equal to box x plus 1, that is equal to box x plus 1, since 1 is an integer. Now, suppose box of x plus 5 by 2, box of x plus 5 by 2, that is equal to box x plus 5 by 2 is this is possible, this is not possible, box x plus 5 by 2 not equal to box x plus 5 by 2, this is possible only in the case of integers, right? This is a very important property, right? Now, if box x less than k, if box x less than k, then what are the values of x? If box x less than k, what are the values of x? Right. If box x less than k and k belong to z and k belong to z, that implies the values of box x are k minus 1, the values of box x are k minus 1, k minus 2 and so on minus infinity, right? The values of box x are minus infinity and so on, k minus 2, k minus 1, right? From this, that implies box x is equal to k minus 1. Box x equal to k minus 1. That means x must be less than k, right? Box x is equal to k minus 1, then x must be less than k, right? Now, second one, if box x less than or equal to k, if box x less than or equal to k, that implies what are the values of x? If box x less than or equal to k, then what are the values of x? Box x less than or equal to k. First, write the values of box x, that is equal to minus infinity and so on, k minus 1 comma k. These are the values of box x, right? Then what are the values of x? If box x is equal to k, if box x is equal to k, then x less than k plus 1. If box x equal to k, then x must be less than k plus 1, right? Now, third one, if box x greater than k, if box x greater than k, that implies the values of box x are k plus 1, k plus 2 and so on to infinity, right? Box x greater than k and k belong to z, then the values of box x are k plus 1, k plus 2 and so on to infinity. Then what are the values of x? What are the values of x? Right? Here box x is equal to k plus 1, box x equal to k plus 1, that implies x greater than or equal to k plus 1, x greater than or equal to k plus 1, right? Now, if box x greater than or equal to k, box x greater than or equal to k, that implies the values of box x are k, k plus 1, k k plus 2 and so on to infinity. Then what are the values of x? That implies here box x is equal to k. Box x equal to k implies the values of x are x greater than or equal to k. X greater than or equal to k. Right. So these are the properties of greatest integer function. Now see the graph of greatest integer function. What is the domain of this function? What is the domain of greatest integer function? Domain of greatest integer function is R. The integral part is defined for every real number. That's why domain is R. What is range? What is range? Range of this function is set of all integers. Integral part means integer, right? So the range of this function is set of all integer, right? Okay, now see the graph of this function. If x lie between 0 to 1, x lie between 0 to 1, x greater than or equal to 0 and less than 1. Then what is box x value? What is box x value? Right. X lie between 0 and 1. Box x is equal to 0. If we take any value between 0 and 1, box x is equal to 0. It means that the integral part of every number between 0 to 1 is 0. So if x lie between 0 and 1, in this case box x is equal to 0. Right. So this is the graph in the interval 0 to 1. Right. Now if x greater than or equal to 1 and less than 2, in this case box x is equal to 1. Right. If x lie between 1 and 2, the integral part of every number between 1 and 2 is 1. So in this interval, the graph of this function is y is equal to 1. Y is equal to 1. That is another step. Right. Now if x lie between 2 and 3, x lie between 2 and 3, then the integral part or box x is equal to 2. Right. If we take any number between 2 and 3, then its integral part is equal to 2. So in this interval 2 comma 3, the graph is a straight line, that is y is equal to 2. Right. Now in the negative side, if x lie between minus 1 to 0, minus 1 less than or equal to x less than 0, box x is equal to minus 1. Box x is equal to minus 1. If we take any number between minus 1 to 0, the integral part is minus 1. So in this interval, the graph is y is equal to minus 1. Right. Now minus 2 less than or equal to x less than minus 1, box x is equal to minus 2. In similar, minus 3 less than or equal to x less than minus 2, box x is equal to minus 3. Right. So this is the graph of integral of real numbers. See the graph, observe that these are the steps These are the graph is steps. So that this function is also called a step function. This function is also called a step function. Right. This is the graph of step function or the greatest integer function. Right. Now now go to one more property of step function. See this box of x by n plus box of x plus 1 by n plus box of x plus 2 by n plus and so on. Box of x plus n minus 1 by n is equal to box x. This is true for all n belong to n. Observe that the LHS contains n terms. How to use this result? How to get this result? Right. Suppose 5 is an integer. 5 is an integer. 5 can be written different ways by using this result. See this 5, that is equal to box of 5 by 2, right? Here n is equal to 2, so we get 2 terms. Here this is n, the LHS contains n terms. Here x is equal to 5 and n is equal to 2, we get 2 terms. Box of 5 by 2, next one is box of 5 plus n minus 1, n minus 1. Here n minus 1 is 2 minus 1, 1 by 2, right? This is equal to 5 or not? Box of 5 by 2 is equal to 2. Box of 6 by 2 is equal to 3. 2 plus 3, that is equal to 5. 2 plus 3, that is equal to 5. Right. Now see, 5 can be written in a different way by using another value of n. That is equal to box of 5 by 3. Box of 5 by 3. Here we choose n is equal to 3. Right. Now this contains 3 terms. Box of 5 by 3, box of 5 plus 1 by 3 plus box of 5 plus n minus 1, n minus 1. So 3 minus 1, 2 by 3. Now verify this value is equal to 5 or not, right? 5 by 3, that is 1. 5 by 3, that is equal to 1. 6 by 3, that is equal to 2. Now this is 7 by 3, that is also equal to 2. So this will be 5. Right? By using this result, we can write any number in different ways. Right? This value is equal to box x. Right? Now replace x by nx in this result. Replace x by nx in this result. We get another result, that is box x plus box of x plus 1 by n plus box of x plus 2 by n and so on. Box of x plus n minus 1 by n is equal to box nx. Right. These two are very, very important results. Right. Now one more function, that is fractional part of x. Right. Fractional part of x. Already in previous discussion we see what is integral part, what is fractional part. Right. Now f of x is equal to x minus box x is called fractional part of x. It is denoted by these brackets or these flower brackets. This is a fractional part of x. Right. Suppose we take a number 6, that is equal to 6 plus 0. Here this is integral part and this is a fractional part. Here we want a fractional part. This is x is a number. Now fractional part is denoted by this, that is equal to 0. Now by using this definition, by using this, that is equal to, here x is equal to 6, box x is equal to 6, box x is also 6, that is equal to 0. Right. Simply fractional part function means it always indicates fractional part of any real number. Right. Now see one more example. X is equal to minus 2.7, that is equal to minus 3 plus 0.3, minus 3 plus 0.3. This is integral part and this is fractional part. Here we want fractional part. Fractional part of x. Fractional part of x, that is equal to 0.3. Or by using this x minus box x, that is equal to, here x equal to minus 2.7 minus box x means minus 3, box x means minus 3. So that is also equal to 0.3. Right. So observing these examples, the definition is derived from this. Let us take any real number x. Let us take any real number x that can be written as integral part plus fractional part. Every real number can be written as sum of integral part and fractional part. Integral part can be denoted by box x and fractional part can be denoted by flower bracket x. Small x is equal to box x plus flower bracket x, that implies flower bracket x is equal to, flower bracket x is equal to x minus box x. Right, that is fractional part of x. Simply fractional part of x means every real number can be written as sum of integral part and fractional part. This function always denotes fractional part. Right. Now, how to draw the graph of this function? Before going to draw the graph of the function, what is the domain of this function and what is the range of this function? Domain of this function is set of all real numbers, capital R. Now, what is the range of this function? Right? Fractional part. Fractional part is always non-negative and less than 1. Fractional part is always non-negative and less than 1. This is the domain and range. Right. Now, how to draw the graph of fractional part of a function? Right. If x lie between 0 and 1, suppose 0, this is 1, this is 2, this is 3, this is minus 1, this is minus 2, this is minus 3. Now this is 1, this is minus 1, right? If 0 less than or equal to x less than 1, 0 less than or equal to x less than 1, then fractional part of x, then fractional part of x, that is equal to fractional part of x varies from 0 to 1. Fractional part of x varies from fractional part of x belong to closed interval 0 comma 1, right? So the graph in this interval 0 to 1 is y is equal to x, y is equal to x, right? So if we take any fraction between 0 and 1, we get the same fraction. It means it is an identity function, right? Now we take 1 to 2, 1 less than or equal to x less than 2. Then fractional part of x is equal to, fractional part of x is equal to, our definition is x minus box x. Our definition is x minus box x. Here box x is equal to 1, right? In the previous case, that is equal to y is equal to box x means 0, sorry, in this case right, in this case our definition is y is equal to x minus box x. Here box x is equal to 0, right? So if x lie between 1 and 2, the graph is a straight line. Y is equal to x minus 1. The graph is a straight line. Y is equal to x minus 1, right? Now if x lie between 2 and 3, x lie between 2 and 3, then y is equal to fractional part of x is equal to x minus box x, x minus 2, right? Y is equal to x minus 2. Now in the interval 2 to 3, the line is y is equal to x minus 2, right? This is a line y is equal to x minus 2, right? Now minus 1 to 0, minus 1 less than or equal to x less than 0, then in this case y is equal to, fractional part of x, that is equal to x minus box x, x plus 1, right? Y is equal to x plus 1. Y is equal to x plus 1 is a straight line, right? This is y is equal to x plus 1, right? If x lie between minus 2 to minus 1, the fractional part is a straight line. Y is equal to, x lie between minus 2 to minus 1, the graph is a straight line. Y is equal to x plus 2, right? Now in the interval minus 3 to minus 2, the graph is a straight line. Y is equal to x plus 3, right? This is the graph of fractional part of x. This graph always less than 1. This graph is always less than 1. This is y is equal to 1. This is y is equal to 1. The graph is always less than 1. The graph is always less than 1. Right. So, domain is R and the range is closed interval 0, 1. Right. Now, Signum function. The Signum function, this is also called signature function. This is also called signature function. Is defined as signum of x that is equal to mod x by x if x not equal to 0, mod x by x if x not equal to 0. If x is equal to 0, signum of x is equal to 0. Right. Now, signum of x is equal to, this indicates the sign of any real number. This indicates sign of any real number. If the sign of real number is positive, then its image is equal to 1. If the real number is negative, its image is equal to -1. If x is 0, x is 0 means it is neither positive nor negative. In this case, the function indicates 0, right? This function indicates sign of the real numbers. If x is positive, that will be 1. If x is negative, that function will be -1. If x is 0, that function is equal to 0. Right? Now draw the graph of Signum function. Right? Before drawing the graph, what is the domain of this function? What is the domain of this function? The domain of this function is set of all real numbers. Range of this function, from the definition, the range contains only 3 elements. They are -1, 0, 1. That is the range. Right? From the definition, if x greater than 0, the graph is a straight line, that is y is equal to 1. That is y is equal to 1. Right. Now, if x less than 0, the graph of this function is a straight line, y is equal to -1. Y is equal to -1. Right. This is the graph of a Signum function. Right. This graph break at 0. This graph break at 0. Right. Now go to very important function, modulus function or absolute value function. Right. The absolute value or sometimes numerical value. Sometimes it is called as numerical value of a real number. Numerical value of a real number is denoted by mod x, is defined as like this. Right? Generally mod x, that is somewhat different way students think this, but simply mod x means it is a distance. Always modulus denotes distance. Right. Here mod x is equal to x if x greater than or equal to 0, is equal to -x if x less than 0. Right. Suppose this is a real line, -infinity to infinity. This is 0, a real number. Mod x means the distance between 0 and the real number x. Mod x means the distance between the real number 0 and x. If x lies on right side of 0, x lies on right side of 0, mod x is equal to x. If x lies on left side of 0, if x lies on left side of 0, mod x is equal to minus x. Right, see one example. Suppose x is equal to 2. This lies right side of 0. So simply mod x is equal to 2. If x equal to minus 2, minus 2 lies on left side of 0. In this case, mod x is equal to minus of minus 2. That is equal to 2. It indicates that 2 and minus 2 are equal distances from 0. Right. Both 2 and minus 2 are at equidistant from 0. Right. This is mod x. Now see the graph of this function. Now what is the domain of this function? What is the domain of mod x? Modulus is defined for every real number. The distance is defined for every point on the real number. That's why domain is equal to R. Now what is the range? What is the range? Distance is always positive. Distance is always non-negative. So that range is equal to closed interval 0 comma infinity. Range is equal to closed interval 0 comma infinity. Right. Here mod x equal to x if x greater than or equal to 0, x less than 0, this is minus x. From this we conclude one more point, that is mod x is equal to x. Mod x is equal to x if x greater than or equal to 0. Now if x less than 0, x less than 0, what is mod x? Mod x is greater than x if x less than 0. Mod x is always greater than or equal to x. If x greater than or equal to 0, simply mod x equal to x. If x less than 0, mod x is greater than x. Right. Now also one more point, if mod x less than a, if mod x less than a, it means that x lie on the real line at a distance of less than a units from 0. It denotes x lie on the real line at a distance of a units from 0, either right side of 0 or left side of 0. That implies x belong to open interval minus a comma a. Similarly, mod x greater than a, mod x greater than a, it means that x lie on the real line which is greater than a units distance from 0, either in right side or in left side. That implies x belong to minus infinity comma minus a union a comma infinity, union a comma infinity. Right. Now see the graph. Mod x, y is equal to x if x greater than or equal to 0. Right. Y is equal to x is a straight line passing through origin. Y is equal to x is a straight line passing through origin, right? If x greater than or equal to 0, this is a straight line, y is equal to x. Y is equal to x. If x less than 0, if x less than 0 means this portion y is equal to minus x, y is equal to minus x. This is a straight line, y is equal to minus x. The graph of a modulus function is V shape. Also observe that if the values of x increases from minus infinity to 0, in this case mod x values decreases. If x increases from 0 to infinity, then mod x increases. So in this interval, mod x is a decreasing function. In the interval 0 comma infinity, mod x is an increasing function. Right. This is the about modulus function. That's all for this session. Thank you.